Hello and welcome back. In this video, we will see how to solve or get the shear force diagram and the bending moment diagram of this simple cantilever beam problem. SFD is the shear force diagram and BMD is the bending moment diagram. And here the length of the cantilever beam is 1.5 meters. Here the length is given, total this full length from A to C, and at the end of the beam 1.5 kilonewton load is applied, and at 0.5 meter from this one end another 2 kilonewton of force is applied. So we need to draw the shear force and the bending moment diagram. So I'll just mark it over here. Just draw the points, draw the lines so that I can draw the shear force and the bending moment diagram at these points. Okay, now we'll solve the first we need to find the reaction at A, and finding the reaction at A we know that we will use the equilibrium, that is sum of force acting along y is 0 and sum of force acting along x direction is 0. Okay, so here there is no force acting on the x direction, so we are going to neglect this and we are going to only see the force acting in the y direction. So to find the reaction at A, that is the force at the A, we will use this equation, sum of forces acting along y direction is 0. Now let us assume that the reaction at A be RA, since the sum of force acting along y is 0, plus these two forces you need to add. So it will be plus 1.5 plus 2 equal to 0. So what we get is reaction at A is equal to minus 3.5 kilonewton. So we have got all the forces at all the points. Now we can draw the shear force diagram. To draw the shear force diagram, we need only the forces. So I'll just draw a line. Okay, and now I will see this is this is minus 1.5 since it is acting in the downward direction. So I'll just assume this one as the point, and here it is minus. So from this point till here it will be a constant straight line, and again it will increase by a distance of 0.5. So here total it is actually 2, but here it is 1.5. So since this is 1.5 and I need to get kilonewton over here, sorry, and I need to get here 2, so I just need to increase this distance by 0.5. Okay, so 1.5 plus 0.5 you will get 2 kilonewton. So it will increase it and it will be constant till the end. So I'm going to mark this. So this will be the shear force diagram of this cantilever beam. Now let us go with now we are done with the shear force diagram. Now let us go with this is SFD, that is shear force diagram. Now let us go with the bending moment diagram. For bending moment diagram, you need to find the bending moment at all the points. At point first, I'll find the bending moment at point C. That is M at point C. MC means the bending moment at point C, which is equal to the force acting. It is 1.5, but the distance is 0. So therefore, the bending moment at point C, you will get it as 0. Okay, since the distance is 0, you will get the bending moment as 0 Newton 0 Newton meter. Okay, and now I am going to find the bending moment at B. Bending moment at B is a sum of bending moment at C plus B. So I'm going to add minus 1.5. This force at a distance of B is at a distance of 0.5 meter from C. So minus 1.5 into 0.5 minus 2 kilonewton, and the distance of 2 kilonewton from B is 0. Is 0. So what we get is bending moment at B is equal to minus 0.75 Newton meter. It is bending moment at B. Okay. So now we have got all the the one more thing is left is bending moment at A. Bending moment at A is the sum of bending moment of at from the force 1.5 and from the force of 2 kilonewton. So see at the point C, the distance from point C to A is 1.5. 1.5 into 1.5, since the force is also 1.5. So I'll get minus 1.5 into 1.5. Okay, so this force is over from this point, and the force here at B is 2, and the distance, so this distance what will be left is 1 meter, because this whole thing is 1.5 and this one is 0.5. So 1.5 minus 0.5 will get 1 meter. So 2 into 1, so force of 2 kilonewton will be acting at a distance of 1 meter. So minus 2 into 1. Here if we solve, we are going to get minus 4.25. 4.25. 4.25 Newton. Sorry, it is kilonewton. And here also it is kilonewton. I forgot to add the kilonewton. So and it is kilonewton meter bending moment at A. Now we have got all the bending moment at all the points, that is A, B and C. And now we are going to draw the bending moment. I'm going to draw a straight line over here, and at point C we are having 0 kilonewton meter, so it will be 0, and it increases linearly. So here at point B I am having a 7.75. sorry, I'm going to just increase it at the bottom little. So I'll just extend this lines. I'll assume it at this point. So it is 0.75. It is negative, so I'm going to draw in the negative eye. This top is positive, negative at the bottom of the line is negative. So here it is a 0.75 kilonewton meter, and at bending moment at A it is given as minus 4.25. I'm going to extend a little bit. And now I am going to mark, say, let the 4.25 be here. So it varies linearly. Since this is a straight line, if the shear force is a straight line, here it varies linearly. Always remember that. If in the shear force, if the force is UDL or trapezoidal load, then it will be a slope. That means you'll get a straight line, slope line. Here it will be a parabolic. Okay. So here, since it is a straight horizontal line, here you will get a straight line. That is the slope you will get, not the parabolic one. So this one is the shear force diagram. This is BMD. And thank you for watching my video. Please do like and subscribe my channel for more videos like this, and comment below for any suggestions. Thank you.